Hey guys, welcome to another video of configuring OSPF topology. In today's video, we'll be configuring the topics as you can see on the screen. These topics, if I'm not wrong, we'll be configuring these topics. And we'll be also explaining the OSPF network types. So without wasting any time, let's get started. So guys, first let's start with the OSPF network types. By default, OSPF have 4 network types, which is broadcast, non-broadcast, point-to-point, and point-to-multipoint. We have 4 network types. Each network type have their own characteristics. So let's dive deep into these topics and our slides. So let's come to the slides. So OSPF network types. Let me zoom in a little bit. So OSPF, let's start with the first one, which is broadcast network type. The broadcast network type is the default LAN interface. It is enabled by default in the LAN interface. When we configure OSPF by default in the LAN interface, it is actually what? Broadcast. This network type discovered neighbors like what? Like it discovered the neighbors dynamically. This network type support DR and BDR. It have an interval of 10 and 40, which is hello is 10 and the dead time is 40 seconds. When you want to configure this network type, like manually, not like we manually want to configure our network type to broadcast. So by typing the command, so by going to that interface that I want to enable the broadcast network type in it, so I will type this command, IP OSPF network broadcast. So let's come to the next one, which is non-broadcast network type. And the non-broadcast network type treat multiple connection as a series of point-to-point links. In non-broadcast network type, we don't have DR and BDR. It is usually used in what? In what we have? And what we have? In one connection. Like, it is used in one connection, and the interval is the hello timer is 30 and the dead timer is 120. To configure this non-broadcast network type, we go to the interface that we want to configure in it. Like interface, I want to configure it on 801. I will go to that interface and type the command IP OSPF point-to-multipoint. No, IP OSPF network non-broadcast. There is some technical issue if I'm not wrong. So you should type the command IP OSPF network non-broadcast. Let's come to point-to-point network type. The network type point-to-point is the default on any point-to-point interface. What are point-to-point interface? Like we have what? Like serial cable. On the serial cable, by default, the network type is what? Point-to-point. So on these interface, the point-to-point network type is by default selected. This network type does not elect DR or BDR. It means that it does not use DR and BDR because we have just one connection with our neighbor and it is just point-to-point. There is no broadcast in it. So we don't need DR and BDR. This network type discovers the neighbors dynamically. The hello is 10 and the hello timer is 10 and the dead timer is 40. On some interface, it must be manually set using the following command. IP OSPF network point-to-point. When you want to change an interface network type to point-to-point, we use what? The command IP OSPF network point-to-point. And that's it. Let's come to the fourth one, which is point-to-multipoint network type. It treats multiple connection as a series of point-to-point links. It's like what we have. Like we have the non-broadcast, but they have their differences. This network type does not elect DR and BDR. In this network type, we don't have DR and BDR. The interval is this network type discovered the neighbors like what? Dynamically, and the interval is in 10 and 30 and 120 seconds. To configure it, we use the command IP OSPF network point-to-multipoint. On that interface that I want to configure it, point-to-multipoint. And we have another interface that is loopback. It is not a network type, but it is an interface that I wanted to explain it for you guys. Loopback is an interface that is used to assign a stable IP address to a router. We use loopback interface that it is an interface that is always up. It is a virtual interface, a virtual network, to make our so that if our router is up and we have connection to it, it do what? It assign a stable IP address to a router. They are always up and provide stable OSPF router ID. We use this loopback interface to provide a stable OSPF router ID to a router. To configure a loopback interface, use the command interface loopback 0, and whatever IP address that you want to give it, it just assign a stable IP address to what? To a router. So that's it. And when we want to add it to our network, we use the command OSPF1 area 0 on that what? On that interface loopback that we have. This is how you can enable OSPF on it too. So using the command OSPF area 0, OSPF1 area 0. So this is how you can do it. So that's it for the network types of OSPF. So let's keep going. As I've told you, in today's video, we'll be configuring this topology that you can see. Let me open my Peanut Lab, Peanut virtual machine that I have in here. Let's open our topology. So this is up, and let's come to our Peanut Lab topology and reload this. And admin Peanut, and log into it. And this is our project. Let's start all nodes. So all our nodes are on. In today's video, I will not be explaining the summary route that we have in here or the ESBR router, but we have configured the area 0 and that route or the neighborship between R7 and R6. So in today's video, we'll be configuring from R6 till R1. All the routers will be configuring the OSPF. So I will not explain it bit by bit to you, but just look and see that how I configure it. So let's go to setup nodes and configure nodes? No, sorry guys. Setup nodes and console to all nodes. So I will console to all nodes, and let's make this one. And I have console to all nodes. I have configured the IPs in these routers because it takes too much time. So guys, you have to configure it yourself. So we have already configured R7, R8, and R9. Let's go to here, come here, enable. As you can see, the configuration, I have done the configuration, and the neighborship have been fully adjacent between R7, R8, and R9 and R6. So let's start the show IP OSPF what? Neighbor. As you can see, I have on R7 two routers, 8.8 and 6.6, which is this one. So let's configure other routers too. So I have configured R7, R8, and R9. So let's just skip these routers and come to R6. Enable show IP interface. As you can see, show IP interface brief. As you can see, I have configured the 801. I will just right now configure the 8.0 configuration terminal router OSPF1 network 192.1.103. What? .0 space 0.0.0.255 area what? 10. And let's come to R5 that we have in here. No, let's put R5 back in here. Let's come to R4 that we have in here. This is a broadcast network type. We have three routers connected to the one switch, and these three routers will take IPs from what? This subnet that we have in here. So let's come to what? R4. So enable configuration terminal. So this is R4. Do show IP interface that we have in here, brief, and we have these two interfaces. So let's configure them. So router OSPF1 router ID. Let's give it a router ID 4.4.4.4. Let's configure the network. What do we have? The first one on 8.0.0.1 192.1.103. What? dot 0 space 0 dot 0 dot 0 dot 255. I want to configure in which area? In area 10. This is number one. Let's configure the another one. Like we have it was what? 100.2. And this is the second one. So let's come to R3, which is this router, as you can see in here. So enable configuration terminal, do show IP inter brief in here. So we have these two interfaces. So let's configure the OSPF on this one too. So router OSPF1, router ID, we have it 3.3.3.3, and network what? What is the network? 192.1.103.0 space 0.0.0.255. In which area? In area 10. And this is the R3. And let's also configure the other interface that we have in here. In network, we have it 192.168.100.0 space 0.0.0.255, area 10. And that's it. And let's come to these three routers have been configured. Let's come to R5, this one. Enable configuration terminal. I have configured do show IP inter brief. I have configured the IPs for these two serial cables that we have in here. So let's configure the router OSPF1, and we have the router ID for it, which is 5.5.5.5, and we have the network for it 192.1.102. What we have .0 space 0.0.0.255, area what? 0, no, area 10. And we have the another one, which is 100 to what? 101. And this is how you can configure the R5. And let's come to R5 is done. So let's come to R2. We don't have R2 in here. And we don't have R3 in here. No, we have R3 in here. Reconnect and do show IP. Oh, I have configured R3 in here. And R5 is also as well configured, R2. And let's come to R2. As you can see, this router enabled show IP inter brief. As you can see, I have configured both the interfaces. So let's come to configuration router OSPF1 router ID 2.2.2.2 network. What is the network? 192. Which router we are? 192.1.101.0 space 0.0.0.255. In which area? In area 10. That's it. And let's configure the other interface, which is network 190, which is 800 192.168.100. What do we have it in here? .00.0.0.255. Area what? Area 10. And let's come to R1. R1, we have R1 in here. We have enable configuration terminal, do show IP interface brief, and this is the interface IP. So router OSPF1 network. First, let's specify the router ID 1.1.1.1, and let's configure the network 192.168.100.0.0.0.255 area 10. And that's it. And that's R1. And we have also, oh, we forget the R11, R1, R2, what do we have? R3 should be in here. And R11. Let's come to R11, reconnect, and enable configuration terminal to show IP inter brief. And this is 192.168.100.11. So router OSPF what? 1. Router ID 11.11.11.11. Network. What is the network? 192.168.100.0. This is also a broadcast network that we have in here. We'll give all the IPs to these four routers that are connected to this switch from the same IP range. So 0.0.0.255 in which area? In area 10. And that's it. That's all the configuration that we need. So let's end this and come down and do show IP OSPF route. As you can see in here, do show IP route OSPF. Control A, and we have it like this. So these are the routes that we have in the IP route. So we have configured from R9 up to R1. No, from R1 up to R9, all the routers. So what is the motivation behind all the configuration, and what is the motivation behind the video that we have in here? So first of all, I wanted to explain the DR and the BDR in a broadcast network. How does it work? So let's come to in which one or in R3, R4, and R6 I will explain it in R1, R2, R11, and R3. So let's come to R1 and this. So if I want to see that who is the DR and who is the BDR, so I will just type the show IP OSPF neighbor. So how many neighbors do I have in here? I have 2.2, 3.3, and 11.11.11. So which router is what? The DR. So the R3 that we have 3.3, this is the router ID of the R3. This is what? The DR. The 2.2 that we have in here, which one? R2. It is what? BDR, which we have full connection with it, and the 11.11.11, which is this one. As I have explained as I've explained it for you, this is the DR other. That if the DR go down, the BDR will become the DR, and this DR other will become what? As the BDR. So this is one thing. Let's come to the next one. I have explained the DR and BDR in here for you. So what is the meaning of two-way and full? So two-way and full adjacent, as I've explained it in the video before that, or the video before and before that we make a fully adjacent connection with the DR and two-way connection with what? DR others. So this is how we make the fully connection with what? The DR and BDR. So R1 have a fully adjacent connection with what? DR and the BDR, which is R2 and R3, but two-way connection with what? 11.11.11. So whenever a networks get down, so R1 will send it to what? To DR and also the BDR. So let's come to primary and backup route. What does it mean? I have explained it in the video before that primary and backup route is primary is the best path, and the secondary route is the backup of the best route. So let's come to which one router, which router, let's come to which router. So which router have two ways to a network. So this one or this one. So let's come to R5. And R5, I will type show IP route OSPF. When it want to go to in a network, so let's make a network in R3. A loopback interface loop 0, and IP address, what we have 3.3.3.3 and 255.255.255.255, and exit and router OSPF 1, and network 3.3.3.3 and 0.0.0.0 space area 10. I have added a loopback interface into R3. So if I come to R5, it should get the IP update for this network. So show IP route OSPF. So as you can see, this network, this loopback interface that we have in here is /32, and we have two ways to go there, which is the best file. The first one is 192.1.102.4, and the other one is, the first link is this one, and the second one is this one. So which one is the best path? So the best path is what, if I'm not wrong, it is the 192.102.4, which is serial 1.1. This one is what? The best path to go there. And this is what? The secondary route. So if this interface get down, or the best path get down, so it will use what? The secondary route. So let's go to interface serial 1.1 1/1. So let's shut this interface. The interface is down, and let's end this. So now let's see, because this was the best path, so now it should be changed to this one. So if we type show IP route OSPF, what is the best path? It is 192.1.101.2, which is which interface? Which is this one, as you can see in here. So if I just go to configuration terminal, interface S1.1, no shutdown. If no shut it, so it will go to what? The primary. It will just become what? The primary route. So end it, show IP route OSPF. As you can see it in here, or I can see it in here. So as you can see it in here, the 102.4, which is this interface, have become the what? The primary route. The problem with the default configuration of OSPF that we have is what? As you can see in here, which the cost, when OSPF want to calculate the cost of an interface, it is 100 by bandwidth. I have explained the full thing in here, that up to 100 MB that we have, the cost is what? 1, which is 100 by bandwidth. So let's take calculator that we have in here. No, I want the calculator. So 100 divided by what? By the bandwidth, which is what? 100. The cost will become what? 1. So what if we have an interface that have the cost such as what? 1 gig. We have a 1 gig interface, and we have another interface which is 100 megabit. How the router will decide that? To select the 1 gig interface, because it is 1000 megabits speed. The speed of 1 gig is 1000 megabit, which is the 10 times more than 100 Mbps. But the router or that we have configured OSPF in it will select what? 100 megabit as the best path, sometimes as a misunderstanding. It just don't differs between 100 MB, a 1 gig and 10 gig. So to solve this problem, we change what? The default 100 that we have by bandwidth. We can change this thing that this number, which is 100, to however number that we want. So let's come to our router. So that we have our 5. So show IP OSPF interface what? S1 by 1, serial 1 by 1. So the serial 1.1 by 1, what is the cost of it? It is what? 64 by default. So I want to change this cost, the cost of it. So what will I do? So I will just type, so on all the routers that we have inside an area, I will change what? The auto cost reference bandwidth. So let's type the command router OSPF 1. I want to change what? Can I paste something in here? Control U, no I can't. So I want to change what? The auto cost reference bandwidth. So I have come to our router OSPF 1. I will do what? I will type the auto cost reference bandwidth. I want to change it from what? Which is by default 100. Let's change it to some number like 10,000, so we don't get into problem. So in here, as you can see, that it gives me, what do we call that? A warning that please ensure that the reference bandwidth is consistent across all routers. So if I change the auto cost reference bandwidth in R5, I have to change it in all the routers in the area that I have. So let's come to R4. Let's end this. Show IP route OSPF. As you can see, I have changed the auto cost reference bandwidth of this one. So let's come to the network 192.1.67. What is the admin distance? It is 110. What is the auto cost reference bandwidth? That is 3000. The bandwidth having what? Changed from the default. I will show you the default also on the screen. in the video. So I have changed what? The AutoCast reference bandwidth in here. So this is how you can do it. So this is the cost. If I want to go to 192.178.0/24, this is the cost of it. And this is the cost for this one. And this is the cost for this one. I have changed it. So I just don't have right now the gig interface in these routers. So if I had the gig interface, you would have get the idea of what I'm talking about. So thank you guys for watching. And if you like this video, if you have liked this video, like, subscribe, and share this video with your friend if they need some OSPF or networking information. So thank you guys for watching. See you in the next video. In the next video, I'll be explaining some other topics that we have in OSPF, and I will show you also the configuration of it. So thank you guys for watching. Bye bye.